This is part 2 of the electrolysis topic on GCSE AQA chemistry. It's a dual and triple award topic. Going to recommend you pause and have a go at the activities as you go. In this video, we're going to build on what we saw in part 1. We're going to look at what happens to the ions in electrolysis, and we're going to see how we can represent it using half equations. To begin, a quick review of the diagram. And hopefully you're able to annotate and explain what's happening here. The positive anode is on the left, close to the larger part of the cell. The negative electrode, the cathode, is therefore on the right. And I'm adding in my ions, which are free to move in the molten lead bromide. Now, where will the ions move to? What will they be attracted to? To help answer this, I've added the diagram again. What do we see happening here, and why are we seeing it? Well, my bromide ions are moving to my positive electrode, negative ions to positive electrode, and my positive ions are moving to my negative electrode, my cathode. So, in summary, positive ions are attracted to the negative electrode, and negative ions are attracted to the positive electrode. So, we know that positive ions go to negative electrode, negative ions go to positive electrode, and we know that opposite charges attract. It's a theme that we come back to in many areas of chemistry. But how are we going to relate that to the names anode and cathode? Because you may need to talk about it in those terms. Well, there's a little mnemonic that helps you to remember. Positive anode, negative is cathode. Basically, we don't panic. Positive anode, negative is cathode. Panic is the mnemonic that helps you to remember that. Moving on, have a think about these questions. And this takes us right the way back to atomic structure and bonding. What needs to happen for a positive ion to lose its charge? Well, let's put it into half equation form. To go from x plus to x, I need to gain an electron. So positive ions gain electrons to lose their charge. The reverse is true for negative ions. They will lose electrons. My x minus has become x, having lost this electron. So now we're going to piece together all of this separate information to try to represent what's happening in electrolysis. And we're going to use half equations to do it. We've got an example here of a positive ion gaining an electron to become solid atom. This is aqueous. We're going to look at aqueous because it has slight differences, and that comes in a later video. But let's consider zinc chloride once again that we saw in the previous video. Have a think about these questions. So what do we think is going to happen at the negative electrode? Well, we're going to start off with liquid zinc ions, and we know we're going to end up with solid zinc. How are we going to do that? We're going to do that by gaining electrons. How many electrons do we need to gain to go from +2 to 0? We need to gain 2. And what are we looking at here? Is it oxidation or reduction? Well, earlier in the course, on the previous chapter in fact, we learnt about oil rig. Oxidation is loss of electrons, reduction is gain of electrons. This is reduction. It's reduction because we're gaining electrons, as you can see here. It's also reduction because we're reducing the charge on the zinc ions. We've got two different ways of looking at that. Now let's consider what happens on the other side of this reaction with the negative ions. So what will happen at the positive electrode, and is it oxidation or reduction? Well, for this one, we're going to start off with Cl-, it's liquid, and we are making chlorine. The chlorine is diatomic. We have to remember it's diatomic, and chlorine exists as a gas. So I now need to balance this equation. I need 2 Cl- to make Cl2. And now I need to balance the charge with electrons. I've got my half equation for what's happening at the positive electrode at the anode. This is oxidation because we've lost electrons. My Cl- has become Cl2 and 2E-. They've been lost. So it's oxidation because it's loss of electrons, and also in oxidation the charge is increased. It's gone from -1 to 0. So now let's try to look at what's going to happen in electrolysis overall. In each of the examples, we're going to look at the ions that make up the ionic compound, which electrodes they will be attracted to, what the half equations will look like at each electrode, and what has been oxidized or reduced. This is the example that we've just done. We've gone through all of that already. Now let's piece it together to try copper chloride. So, what ions make this up? Well, chlorine is in group 7, so it forms charges of -1. There are 2 of them, so the copper is +2. Copper is the positive ion, so that's attracted to the negative cathode. Chloride ions are negative and attracted to the positive anode. So what's going to happen at each one? Well, the copper ions are going to gain 2 electrons to become solid copper, and at the anode, 2Cl- will become Cl2, having lost 2 electrons. Finally, at the cathode, we have reduction because we have gained electrons. At the anode, we have got oxidation because we've lost electrons. Let's try another example. So MgBr2 is going to be made up of Mg+2 and Br-. There are 2 of them. Bromine is group 7, -1 charges. Magnesium is group 2, so ions will have a charge of +2. The magnesium will be attracted to the cathode because it's a positive ion and the cathode is negative. The bromide ions are negative, so they are attracted to the positive anode. So now we can do the half equations. Mg+2 gains 2 electrons to become Mg. State symbols are important here as well. And at the anode, 2Br- becomes Br2, having lost 2 electrons. At the cathode, we have got reduction because electrons have been gained. At the anode, we have got oxidation because electrons have been lost. You might be spotting other patterns here that are going to help you to remember it. Let's try ZNO. So this is made up of Zn+2 and O2-. We know oxygen is a -2 charge because it's in group 6. Zn must be +2 to balance the -2 charge to get to an overall charge of 0. The zinc ions are positive, so they're attracted to the negative cathode. The oxide ions are negative, so they're attracted to the positive anode. And from there we can do the half equations. So the cathode and the cathode, I have got Zn+2 gaining 2 electrons to become Zn. And at the anode, I've got to be careful with the balancing here. 2 O2- become O2, having lost 4 electrons. At the cathode, we have reduction, and at the anode, we have oxidation. And let's have a look at a really simple pattern just to finish off. We've spoken about lots of patterns here. Reduction always takes place at the cathode. Oxidation always takes place at the anode. That takes us to the end of this video. Thank you for listening, and goodbye.